This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
So welcome to a new episode of SE Radio. Today I'm talking to Jay Fields about the topic of unit testing, actually working effectively with unit tests. So Jay, welcome to the show. And why don't you start us off by introducing yourself?
Yeah, great. Thank you very much for having me. I'm Jay Fields. I work for DRW Trading, and before that I worked for ThoughtWorks, so I have a bit of experience with consulting and a bit of experience working full-time. And I think those are both great environments, and I'm glad I've gotten to work in both. And it's given me exposure to various ways to unit test, and hopefully I've found something that can make other people productive as well.
So my assumption would be that probably 100% of our listeners know what unit tests are and are using them, but I may be wrong. And even if I'm not, I'd still like you to explain to us what a unit test actually is and how it differs from other kinds of tests.
Yeah, absolutely. Unit test is a very tricky term, in my opinion. If you asked 100 people, I'm not sure you'd get the same answer from anyone. And recently I was really trying to influence the community to make a more strict definition of unit test. And Martin Fowler basically convinced me that was a terrible idea, because I'm never going to be able to convince the community to come up with anything more strict. If you go to Wikipedia, you can see that the definition on Wikipedia is: in computer programming, unit testing is a software testing method by which individual units of source code, sets of one or more computer program modules, together with associated control data, usage procedures, and operating procedures, are tested to determine whether or not they are fit for use. So it's not a great definition, in my opinion, because it's basically saying individual units. So units could be methods or functions, but then it says modules, which could be entire components of an application, procedures, operating procedures, usage procedures. It's just very general. And I think it almost reduces to tests. I mean, there's not much specific about it.
Mm-hmm. So what do you see as the critical or as the best size of one of those units? When do you think it's justified to call something a unit test as opposed to?
It depends on the language, obviously, but my experience has been in Ruby, C#, Java, Clojure, and in the object-oriented languages, I prefer to test at the method level. So maybe one test fixture, so one class. One test class for every class in the application, and then one to many tests for every method that needs to be tested. And then in functional languages, probably one test namespace for every domain namespace, and one to many tests for every function that deserves to be tested.
So the original article on the topic was called Test Infected. Programmers love writing tests. Do you think that's true? Do programmers love writing tests? And if they don't, what's a good way to get them to love tests?
I think the first time you start writing tests, you fall in love with a couple things, assuming tests are for you. I think you fall in love with the fact that you can kind of play around in there, and you know that there's unlikely to be impact in production code. So you can experiment a little in your tests. And I don't know many programmers that don't love experimenting. And I also think they fall in love with the confidence that you can gain from writing tests. So it's very easy to fall in love with code where you can be playful and then tell yourself that, there's also value to this code. It's giving me confidence in my application. For people who don't necessarily love it, I think they would maybe fall into two categories. People who simply believe they don't have enough time to write tests, and I think that's just a terrible justification. I mean, if you don't have time to write tests, it's possibly because you're always debugging, and maybe you wouldn't have to debug so often if you were writing tests. Or it may also be people that have worked with tests that haven't provided them as much value as they'd expected. And for those people, I would encourage them to not necessarily dive back in, but maybe see if there's another way that they could write tests that would provide them more value in the future, and maybe they'll fall back in love with writing tests.
Would you say it's a fair characterization to say that a unit test is the test that you mostly write for yourself, that you have the most motivation to write to gain personal benefits from it? Is that a fair characterization?
I think that's what most people do, absolutely, especially people who are in love with unit testing. I think that most people approach unit testing from the frame of mind of what's best for me right now in creating some new code, creating a new feature for the first time, and what's best for me when I want to maintain it. And I would say that's actually not necessarily great. I think in general, you probably want to put the team first. And maybe if you put the team first and the team put the team first, maybe you wouldn't run into so many tests that are painful to work with.
So from a programmer's perspective, I think unit tests are the easiest form of test, or at least they seem very easy. Given that is the case, or that most people think that's the case, why did you end up writing a book on the topic? And in fact, why are we recording this episode?
Sure. I think that unit tests are very approachable. They're very easy to write, and they're even easier maybe to write poorly. And it's funny, when I first started writing this book, I contacted Martin Fowler and just said, hey, I'm thinking about writing this book, and I have 3 chapters. Maybe, if you have some free time, you can take a look. And he replied right away and said, I don't know why you're writing about that. The space really seems pretty mined out, were his exact words. And it really put me off. I respect Martin quite a bit. And I thought, man, if he thinks this is a bad endeavor, then I should probably give up right away, to be honest. Luckily for me, a couple other people said, I think that what you have is pretty good, and I think you should keep going. And eventually, I don't even know what happened, but Martin had access to the book the whole time as I was writing it. And one day he said, hey, I heard you finished, and so I'm going to give the book a read. And a couple days later, he said, this is really, really good, and I hope that you get the word out. I hope people read this book. And the thing that hopefully other people find valuable, that I think he thinks is valuable about the book, is that it gives unit testing, it gives you a view into unit testing from someone's point of view. It gives you what I think is a practical way to approach unit testing. And I don't think you see a lot of that out there. I think there are really good beginner books, and there are books that give you a lot of different detail. For example, the X-Unit books give you a lot of detail on pretty much everything that you could possibly think of. I don't remember how long that book is. I know that I never got through it cover to cover, but I think it's maybe 700 pages long. Fantastic reference manual. And then another book that I got through recently was The Art of Unit Testing. And again, I think it's a great book, but it's an intro book. And so I think there's a void there. There's a space for more people to write about not just, the hello world of unit testing, writing that first test and setting up the framework. There's a big gap between that and then the reference material that says, here are the patterns for unit testing. I think that the community as a whole could benefit from a couple books where people say, here's how I like to write my unit tests. Here's the guidance in kind of the big picture way. A blog post here and there about unit testing is great, but we have 10 years of blog posts from very talented people, but no comprehensive view into how these people work effectively. So that's really what I set out to do in the book, was take a lot of the experience that I've picked up over the last dozen years and put it together in a way that shows more than the trivial blog post example. It takes a domain that people are familiar with and takes some tests that look about as terrible as you would expect if you're a consultant or a full-time employee that picks up somebody else's code base, and evolves the tests in very concrete ways, showing, basically every line evolves them to what I believe is a more maintainable style of unit testing.
So what is an example, or what are some examples of things that people do wrong when they write unit tests?
I think mostly all of it stems from thinking about yourself, thinking about what's going to make you successful right now. A lot of people conflate test-driven development and unit testing as if they're the same thing, but they're not. And a test that you wrote to help you create a feature, a test that you use to TDD a new feature for your application, that test is not guaranteed to be valuable for you in the long term. So just because the test helped you write the feature, there are a lot of things you can do from there that I don't think people do. You can, first of all, just delete the test. If you just wrote a test because you weren't really sure how you wanted things to work, and you now have a working feature, and that feature is nice to have. Maybe one user wants to use this feature every 3 months, and if things go wrong, nobody cares. You get a phone call and maybe you update a database table yourself or something trivial like that. Do you really want to strap yourself with additional code that you have to maintain over time? I mean, it's more likely that that feature will change to be maybe more valuable or maybe go away than it is that a bug will creep in and that test will save you. And, like I said, if you look at the test and you think, what's the return on investment for this test? ROI is something I like to use a lot when I talk about tests. So if this test is going to save me from getting a phone call once every 6 months, then maybe I don't want to maintain it in my code base. So the first thing that I think you have to do is look at your test and determine, okay, it helped me TDD, fantastic, but does it still need to be here? And if the answer is no, then you need to delete it. If you think that it did help you and you think that it is important, let's say you're writing an insurance application that needs to look up customers by, you're in the US, so social security number. And this seems like a pretty important feature, being able to look up your customers. So you wrote a test that helped you TDD it, but that doesn't mean that that's the best test that's going to help you maintain that code. So look at the code again. Maybe if it's really critical to your application, grab somebody else and say, if this test were failing right now, what clues would you want in order to figure out the source of the problem as fast as possible? And change a test to go from helping you deliver a feature to helping you maintain value in the system.
So the very first difference seems to be that if you do test-driven development, if you use tests to just create the code in the first place, that might mean that you have something different than what is useful in the long run. So assuming that you create something that you want to be valuable in the long run, what are some things that you have to think about? What makes a test good and maintainable under that circumstances?
I would say approachability is key to start with. So whenever I see your test failing, a test that you may have written 6 months ago and you've long since moved on, and I've never seen it before, what kind of clues does the test give me? Does it tell me where I can look in the domain to figure out what's going on? I think another thing that bothers maintainers in general is how much test code do you have to wade through before you can figure out what's actually wrong. If you have, say, a test that someone has used dry to kind of make, most people apply dry in a way that ensures that the least number of characters are used, but that's not necessarily the best way to write a test.
You're talking about dry as in don't repeat yourself, right?
Yes, exactly.
Okay.
If you come to a test for a first time and it's failing, and, more than likely when a test is failing and it surprises you, it's because it seems unrelated to what you're doing. So you're annoyed because you want to move on. You're in the middle of delivering some feature and you see something that looks like it's unrelated, and so you're annoyed as to why it's breaking. So if you open it and you can pretty quickly figure out what's going on by just looking at the broken method, the test method, then you're probably not too annoyed and you just move on. But if you open it and there's some variable in there, some field level variable in a Java class, I guess, and it's initialized, maybe it's declared at the top and then it's initialized somewhere, but you don't really know where. So now you have to find usages. So maybe you find a setup method, or maybe you find a helper method or something like that. You start navigating around and you're just moving farther and farther away from what you wanted to do, which was just deliver a feature that seems somewhat unrelated. So I think not necessarily, specifically, I think repeating yourself in ways that will enable someone that's never seen the test before to more quickly understand what's going on can be a good thing. When you're looking at a test suite as a whole, if there are ways that you can get rid of duplication, for example, running all of your database updates in a transaction and then rolling everything back is obviously just a good idea. When compared with trying to do that in every single test individually. So that's great. Apply some type of dry to the test suite level. And then within a test, obviously, you probably don't want to repeat too many things. But when it comes to a grouping of tests, for maintainers, maybe the best thing is actually not knowing that there's a grouping of tests. I mean, when's the last time you saw a grouping of tests and they all failed together? When they all fail together, then you look at all the infrastructure code and it's valuable because it all makes sense in the grouping. Mm-hmm. But when 2 out of 5 fail and you need to understand all of the logic built into the grouping, then you've spent some decent time understanding that logic, and that was helpful to 2. But every second that you spent trying to understand the infrastructure that applies to the other 3 that are still passing is basically waste. Mm-hmm. So avoiding reducing the code or the characters specifically as much as possible, I think is a great way to create more maintainable tests. Again, just considering what the value of the test is. You know, it's at first it's for creating, but after that it becomes about maintaining. I think you also want to avoid pretty much any type of looping constructs or reflection if possible. Basically what you want are straightforward tests that you can easily navigate, and only when necessary, and only navigate into domain code if possible.
Mm-hmm. So there seem to be different rules for the test code as for the rest of the system. Do you consider it a necessity that the test code is as maintainable as the production code, or more or less? What's your feeling there?
Sure. When I first started consulting at ThoughtWorks, I used to, at dinners, talk to some of the other team members, and I would ask them the silly question of, which would you rather have, a perfect test suite or a perfect code base? And, inevitably they were pragmatic and said a perfect code base. And I would always say that makes no sense, because a perfect test suite would guarantee that the code base was perfect, which is really not true. I mean, mm-hmm. If the test suite were perfect, then it wouldn't have tests that must be maintained for features with small return on investment. So you can't guarantee that the code base is going to be perfect if the tests are perfect. So the first thing I would say is it really makes no sense, even from a high level, to approach the 2 pieces of code in the same way. The test specifically should be approached from value, in my opinion. What's the value of the test with respect to keeping the application up? Whereas, in production, obviously, pretty much all code should be treated pretty equally. I mean, a bug in some trivial feature could just as easily take down the system with an exception, I would assume. Mm-hmm. So yeah, you want to apply different thinking to your tests, and you want to also, you really want to approach the tests in a way where perhaps readability is more important than performance. But at the same time, performance is still going to be important enough on a different scale. I work in the trading industry, and often milliseconds are important to us. And when you're looking at tests, individual milliseconds for tests, probably not a big deal. But when the test suite starts to run at around 10 minutes or something ridiculous like that, then you have to wonder if people are even going to keep using the test suite. So there are a lot of trade-offs, but I think you start with readability because you want people to be able to maintain your tests. And then you start making trade-offs where necessary.
How much is this related to the debate that recently was going on between, I think, Kent Beck and Martin Fowler and David Heinemeier Hansson about unit tests are a waste of time? I think that was the original statement made by DHH, by David Heinemeier Hansson, the creator of Ruby on Rails. What's your take on this whole thing? Did you follow it, and what do you have an opinion on it? I
did follow it, and I would agree. It sounds like his tests are a waste of time. You're going to get what you put into it. And I think that it's very, like I said before, it's very easy to write terrible tests, and it's very easy to then blame the tests. And to be honest, I would advise every single person out there who's writing tests that are not making them more productive to just stop. I mean, if they're not making you more productive, you shouldn't do it. You can replace test there with any activity. Any activity that's not making you more productive seems like a no-brainer to stop. I mean, given no other motivation. So I think when you get to that situation, you really have a choice to make. Do you want to continue to, obviously you should just stop writing tests that aren't making you more productive. And so I'm sure their tests were a waste, and I hope that they did delete them and thus they're dead. But that doesn't mean that everybody is spending time that they shouldn't on testing. I think there's plenty of unit tests out there that are very helpful. I mean, my team's working on several code bases that are several years old, and I think the longest running test suite is 10 seconds, and that includes going to the file system, database, whatever crossing boundaries we have to do, and we find all types of issues with our unit tests, and they make us more productive. But, like I've been harping on, we also keep an eye out for tests that make us less productive, and we delete those tests quickly. So I actually applaud DHH for coming out and kind of saying this sacred cow is not necessarily what it's made out to be. And I think more people should delete their tests if they're not finding them helpful. But then they have a choice to make. Do you want to just go without tests? Do you want to go without that confidence? Because it wasn't all bad. You didn't start out with a test suite where it was all bad. At some point, it was probably providing you value. So do you want to invest in trying to write better unit tests? I mean, that'll be up to the individual, but it seems to me like it's something worth investing in, unless they found some other way to get confidence in building systems. But I don't know. I haven't seen a lot of that out there.
Mm-hmm. So I had originally planned to ask you whether there is such a thing as having too many tests, but I think you've just answered it, right? There are too many tests if they're stupid tests. If they don't bring value, then you shouldn't have them.
Yeah, I think too many tests is the same as not enough tests. In both cases, it's suboptimal. You don't, whether you waste time debugging because you don't have enough tests, or you waste time maintaining tests that don't need to be there, at the end of the day, both of those things amount to waste.
Mm-hmm. So what do you think about a metric like code coverage? Is that a useful thing?
I do think code coverage is a useful thing. I remember when Relevance, was now Cognitect, was putting 100% code coverage in their contracts, and I thought it was pretty cool. I thought it was a great idea, but they don't do that anymore, and most people I know aren't looking for 100% code coverage because you have to do silly things. For example,
testing getters and setters.
Yeah, exactly. That's exactly what I was going to say. Also testing framework methods. I personally don't have any desire to test Joda time ever again. I'm going to go ahead and expect Joda time works, and I want to use it without having to fight some silly test coverage battle.
Mm-hmm. Makes perfect sense. So, okay, let's talk a bit about some of the different ways, or some of the different aspects that one might want to test. So, what are some different things that you might want to test for, and how would you go about it?
For me, it's always just the most complex parts of the system that provide the most value. That's all I really look at. So I spoke before about the insurance company, and an insurance company that relies on social security number in order to find their customers. So were I writing that system, I would probably have a lot of tests around trying to ensure that the social security numbers were valid, and I would, we want to bill these people, so I would have tests around credit card validation, and I would have tests around billing addresses, and then I would shy away from tests such as ensuring that their name is alphanumeric, because number one, people seem to be using numbers now, and in the past, I imagine we would have tests that checked for that, and now you have to switch those tests to alphanumeric. But at the end of the day, does it really matter? I mean, as long as the billing is going through, and if the customer really gets upset about having their name misspelled, then they call you, and it's some call center person that updates the name. It's not really a big deal, So that's what I look at from determining how important a test is. If the system needs the specific feature in order to work, then it needs to be tested, and all corner cases likely need to be tested. That needs to be the robust part. If the system can continue functioning without much impact or with no impact, then I would say those are the tests that have less value, and those are the tests that I would look to not have.
Mm-hmm. You mentioned in passing that your 10-second test suites hit the file system and hit the database. I've heard people express the opinion that this doesn't even qualify as a unit test if it does something like that. What's your take on that?
Yeah, in the first version of the book that I wrote, that was exactly how I defined it. I said that unit tests were not allowed to cross boundaries, so no messaging, no file system, no database. And they also would only specify concrete classes for the class under test. And like I said, Martin Fowler got a hold of me and said, this is just it's not going to work. You're not going to convince the industry that this is how to unit test. There's just too much momentum from people who believe that unit testing is allowed to hit the database. And he convinced me that it was a bad plan to try to redefine it. And I've come to terms with the fact that unit testing is just such a general term that you just have to roll with that. And then there are other terms that can allow you to express your ideas. So you can have tests, whether you want to call them unit tests or not. You can have tests that don't hit the database, that don't hit the file system, tests that you explicitly know are going to run fast, and that's why you avoid those things. And then you can have tests that you know are going to run a little bit slower, and they are going to hit those things because that's what you need to do. At some point, you need to hit the database and ensure that you can have a bunch of tests that run really quickly and mock things out, and that's great. They give you some confidence, but at the end of the day, you want at least one test, I would imagine, that hits the database to ensure that integration is correct.
Mm-hmm. In your book, there's a categorization of tests. You have different kinds of unit tests. Can you walk us through some of them and explain what you address with those categories?
Sure.
So I've picked a few. So the first one would be a state verification.
Yep. So state verification, I'm not sure if it was first defined in the XUnit patterns book, but that's the first time I ran into it. And the definition is you inspect the state of the system under test after it has been exercised and compare it to the expected state. So it's all basically about setting up some state, running a little bit of code, and then verifying the state is as you expect it.
Mm-hmm. That would be like trying whether I add something to the system. I want to see whether it's there after I've added it. That's the kind of thing.
Yes. You're more likely to do, say, an assert equals to verify that the value is what you think it would be.
Mm-hmm. The next one is the behavior verification.
Sure. Also, I believe defined in XUnit patterns. Well, definitely defined there. I don't know if it originated there. It's capture the indirect outputs of the system under test as they occur and compare them to the expected behavior. So in this case, you're actually comparing the behavior. You're not necessarily comparing the results of the behavior. So an example would be maybe checking something out of a library, and instead of looking at the state of the library and saying that book is there, and then you check it out, and then you look and say that book is not there, that would be your kind of state-based classic example. Instead, you mock the library out and you say, well, I mean, I guess there's before and after, but some frameworks would allow you to say, I'm expecting someone to take this book from me, and that's your verification. Other libraries would just say, I'm a mock library, talk to me later, and then you take the book out of the library, and then you say, hey, by the way, I'd like you to verify that I took the book out of the library. So that's behavior verification.
So what do you gain from categorizing tests this way? Does it allow you to talk about them differently, or are there different rules for those different kinds of tests?
In a good and a bad way, I think there are different rules. I'm not sure that there's actually, for me personally, there's no winner. There's no better way to test. There are definitely people who prefer behavior verification, and specifically, I think Growing Object-Oriented Software, GOOS, is a fantastic book that really focuses on behavior verification. But people have been doing state verification for years, and it's not like they're failing. So at the end of the day, I think you really are best served to look at both and see which style fits you the best, and then go from there. I would say, for me, it's always been a mixture of both. I prefer to do state where possible, but there are definite aspects of behavior verification, such as stubbing out collaborators, that I found far superior to working with concrete collaborators. So it's worth every software engineer's time to get familiar with both and read all of the literature that they can on both, and then make a determination on what they see as more successful.
Mm-hmm. You have a category of unit tests which is called unit tests. I was kind of puzzled by that.
I think it was just the unit test umbrella. There are a couple of different definitions within unit test. Well, so Martin Fowler, again, convinced me that trying to redefine unit test would be a terrible idea. So I think that there are two subcategories of unit tests that are valuable. Specifically, the tests that we talked about a little while earlier, tests that don't access the file system, don't cross any boundary, no messaging framework, no database. I like to call those solitary unit tests. And solitary unit tests also focus on testing a single class at a time. So in the example of libraries and books, you could theoretically test not only a library, but also the books in the library within your library tests. But I would consider that to be more of an integration test, something that, integration of the classes, something that I like to call a sociable unit test. So a solitary unit test would focus exclusively on the library within the library tests, and it would probably rely on stub books. And a solitary book unit test would test all of the attributes of the book. And the value in this distinction is at some point you're going to make a change to the book. And you have to decide how important is it to you that the book tests fail, probably important, and how important is it to you that the library tests fail whenever the book changes. If you're looking for that level of integration and many examples of that level of integration, then maybe you're fine working with sociable unit tests all the time. But if you would like to be able to change the book without having to touch the library tests, basically avoiding cascading failures, something that I like to put a lot of effort into, then instead you can, again, work with what I like to call a solitary unit test, which will stub out the books whenever you're working with the library, basically isolating you from the changes within book. I think the don't cross boundaries thing is pretty common. I'd be surprised if people hadn't run into that at some point, and it's basically just a speed thing. Nobody wants to, again, I think nobody would even rely on a unit test suite that took 10 minutes to run. So the real combo that I like to do, to be honest, is let's say that you have this library example and you want to check out books, and let's say for some reason the library charges. So the library charges for these books, and you want to verify the cost of checking out a book. So you have book tests, and you verify all of the charges within your book tests. And then the library itself has an inventory, and you also test the inventory and everything else that's interesting about the library in library tests. These tests are completely isolated. Maybe the real library has some type of connection to a file system or a database, and you mock that out you stub that out specifically during your library tests, your library solitary unit tests. And everything runs quickly, and everything's wonderful. But like I said before, at some point, you want to know that when you go to check out a book from the library, that book is going to be out of the database. This is going to be important. And so what I like to do is write as many solitary unit tests as I possibly can, and then write one or two sociable unit tests. That way, I have confidence that the integration of everything works, but I don't have to test my corner cases with slow and brittle sociable unit tests. I can test my corner cases with fast and robust solitary unit tests.
As you mentioned the terms, I have to just briefly ask you to explain the difference between a stub and a mock.
Sure. A mock is used primarily in behavior-based tests, or in my opinion, should be used primarily in behavior-based tests, and actually used for verification. So in the case of the library where you want to check out the book, you could create a library mock, check out the book, and then ask the mock if the book had been checked out successfully. And that asking is the key and the important thing, in my opinion. You don't really want to create mocks and not verify, although unfortunately that's a bit common to do in Java. Stubs specifically, you don't verify. They just always return canned simple responses, and you never really have to worry about their interactions.
Okay. So if you mentioned that before, if you look at a code base, if you look at a test code base, you sometimes get the feeling that something's horribly wrong. What are some of those things that people can improve about their tests? What are some specific things to look for and change to make the tests better, apart from throwing them away if they make no sense?
I think there are a bunch of small things that you can do to really help the team out. So number one, just get rid of the setup methods. Well, actually, before that, get rid of any loops. Any loops in the code base are probably just going to confuse. So split those up into individual tests. Then you can look to get rid of the setup method, because you don't open a test class, see a failing test, and get some immediate alert that, hey, you should go look in the setup. But really, that would be helpful, right? If it told you, this isn't the whole story. So I think getting rid of setup and putting the whole story within the tests is another valuable thing to do. I also can't stand expected values that are not literals. It bothers me to look at a failing test and to say, all right, I have a failing test, and I have a method call for the expected value, and I have a method call for the actual value. And now I have to figure out both to try to find which is wrong, because expected values can be wrong also. Mm-hmm. So I personally prefer to expect literals. Sometimes you can't expect a literal. In the case of a money object, maybe you want to expect a money object, or really any value object, to be honest. You really have two paths there. You can either say, perhaps money.toDouble, and then use a double as your expected value, and then you're back to expecting literals, and that works well. Or I think you could also write custom assertions. And custom assertions are great because they can also be tested, so you have confidence that they work as expected. So I would say either expect literals, or write a custom assertion for any value object that you're testing, but make those your expected values. After that, it starts to get more controversial, and I would say, people should try things and then use what they find valuable. I personally believe in the one assertion per unit test rule. I'm pretty disappointed when I find multiple assertions in a test, and maybe the first or second assertion fails, and now you're left in the position of two, in my opinion, inferior choices. You either fix the first assertion and then mentally try to decide if the other assertion the remaining assertions will pass or fail, which is annoying. You shouldn't have to look at that yourself. There's no reason for that manual effort. Mm-hmm. Or you have to run the tests, and then if another one's broken, then you fix that one and then rerun the tests and continue this loop until things work. So I think it's superior to have one assertion per test. After that, really the big one that I recommend to people are just creating builders. Object Mother was a famous pattern for a little while, and it's very scenario based, and it works very well when you first start using it, but then it starts to break down as you need more variation on data. But Nat Price wrote tons of material years ago on creating test data builders, and there's an upfront cost to creating the data builders, but after you create the data builders, kind of the data builder framework, if you will, then you can very succinctly create test data within your tests that allow you to, without a setup method, quickly instantiate objects and see how they're interacting and understand an entire test without having to navigate to helper methods.
Talk a bit about this object mother pattern, because I'm not sure everybody's familiar with that.
Sure. I think it was, I don't know where it was invented, but I was first exposed to it at ThoughtWorks, and it was pretty simple. You would just say, I want a customer, and there would be kind of a persona, if you will, of customer Bob and customer Mary and customer Joan. And Bob would have a couple attributes, and Mary would have a couple attributes, and Joan would have a couple attributes, and they would be complex. There would be entire object hierarchies or a graph, if you will, of the different attributes. And so this person may belong to this organization and may have this birthday and may be related to someone else. And, perhaps one of these people has 2 children and another person has no children. And you have this persona that you use within your system, and that's great. whenever that's what you need. Maybe you have 4 personas that go out through the entire system and you always use them, and you start to think of them almost like a teammate. All I need to do is write a test for Bob to be off on Tuesday in my calendar program. And the whole team knows who Bob is and what all Bob's attributes are. And that works out pretty well. But then when you want Bob except he lost his job, or Bob except he no longer has a car, and then you start changing Bob around, and maybe Bob's immutable, but if Bob's not immutable, then the order of test running can have some type of impact, or you have to rely on reinitializing Bob every time. And so basically, once you start sharing Bob around in multiple tests, then you start to run into problems pretty quickly. And basically, as a reaction to these problems, well, at least I believe it was a reaction to these problems, people moved to the more general test data builders, which don't have a Bob or a Joan or a Mary. They just have a customer. And when you want a customer with a job, you create a customer and you give that customer the job. And by default, the customer doesn't have a job. And that's it. You look at a test and you can see, I have a customer. Oh, and that customer has a job. Great. I don't have to look at a test and say, I have a Bob. I don't remember if Bob has a job or not. Let me look into that.
Okay. So we've talked about individual tests. Let's talk a bit about the whole picture of a set of tests. I think we've talked a bit about it by mentioning that some tests are more valuable than others. But is there something else that one can use as a pattern to come up with a good set of tests, something that makes sense as a whole? How do you look at the big picture?
My approach to test suites in general is I think there's value in, most tests that people come up with these days. And it's just a matter of getting the ratios correct. So for me, I like to make everything as solitary as I can to begin with. So these days I'm working with Clojure. It's a kind of a functional language. Any function that has any value and any corner cases or any branches within it, I guess, I will test that as a solitary unit test as much as I possibly can. So follow all branches, different test data inputs, basically try to test it as much as I possibly can, but in isolation. And from there, I want to know that it works within the system. So I'll go to a higher level, maybe the other functions that rely on the function that we've solitarily tested, and I'll verify that the integration works. So, maybe you have a piece of code that has 2 inputs and it has 2 branches. And so you think 10 solitary unit tests are reasonable. That's great. Now you have confidence on your 2 branches and your 2 types of input. You probably only need 1, maybe 2 sociable unit tests at that point, because you've already covered the behavior of the function very well. So now all you really need to test is the integration of the function. So you're likely to be able to do that with significantly less tests. So really, you may be able to get by with 1 sociable unit test at that point. Just 1 sociable unit test to verify that the function integrates as you'd expect. So I kind of work with ratios like that, make every single thing that I can a solitary unit test, and cover every single branch that I possibly can with solitary unit tests. And then at the point where a branch can't be covered, or at the point where I need to test integration of that function or method, then I write a sociable unit test, and I write only as many as I need to verify the integration. And that works pretty well. And then after that, I do believe in the value of higher level tests also, which live under so many different names. But I don't know, I guess we could call them integration tests. A high level test that will bring up an entire component of the system. So those are valuable. And I'm trying to remember, somebody came up with the test pyramid. I can't remember off the top of my head, but Martin Fowler pointed me at that also. And that seems like a very reasonable approach. So at the bottom, you have a very wide base of the pyramid, and that's where all of your solitary unit tests go. And then in the middle, you have your sociable unit tests, which help you verify that everything is collaborating in the way that you'd expect. And at the very top, you have your highest level tests, your high level tests that verify that the system, maybe from its inputs and outputs, is working as you expect. So maybe you find a way to send a message through an actual messaging system into a running process. And then you look in the database or you look in the file system to see that the system reacted in the way you'd expect. So I believe there's value in those as well. I don't call those unit tests, but I do call them, I guess, high-level tests most of the time. And I think those are great. That's a great complement to your unit tests, as long as you can keep them under about a dozen. Once you get past a dozen, I think they become a little bit unmaintainable. So I guess you can maybe extrapolate some numbers from there. Maybe a dozen high-level tests, and then, I don't know, maybe 100 or 200 sociable tests, and then from there, it's going to depend on the code base, obviously, the size of the code base. But it seems hard to believe that you would need more than 2,000 solitary unit tests because, I don't know, it just seems hard to believe that any system has that many functions that are critical, absolutely critical to its functioning correctly.
So what do you think is a reasonable relation, a reasonable fraction of the time that developers should spend on writing tests versus writing production code? Does it make sense to ask the question, or is it stupid?
Wow. It's a new question for me. I don't know. I've never really thought about it. I mean, in some ways, you would say that maybe 50-50 would be reasonable. In some ways, you would say that if you write the test and then you implement the simplest thing that could possibly work, and then you readdress the test to make sure that it was going to be good for maintenance, then perhaps you'd spend more time on testing. I would say you have to balance that with, well, I don't test every single thing because some things are not as important as others. So I would say that I probably spend 40% of my time testing, and that's a combination of unit testing, high-level testing, and manual testing. I think that's a pretty reasonable percentage. Anything between 30 and 50%, I think, would be reasonable. If you're over 50%, maybe you're doing something wrong. I mean, if you're over 50% because you're doing TDD, and then as soon as you're done implementing features, you're deleting those tests, then maybe you're fine. But if you're spending more than 50% of your time in the tests because you have brittle and unmaintainable tests, then I think something's wrong.
You mentioned that you're doing development in Clojure these days. Just as a more general kind of question related to that, how does unit testing change when you use a different programming language, or does it change at all?
I was trying to think of a good example of what I do differently. Right after I mentioned Clojure, I thought, how does this really apply based on my Java history? And I don't know that there's really any difference. I mean, to me, I've given such general things that are important to me when it comes to testing. It doesn't really matter what language I'm working in. A test is either testing a feature that is important and therefore needs to stick around and needs to be readable, or it's not. And it doesn't matter if that's state-based or behavior-based, or in Clojure or in Java. They're just kind of higher-level rules that I think go beyond language and domain and approach. At the end of the day, you really want to stick with tests that are valuable and tests that are maintainable for the team. Some things, I guess, could be different. You would think that testing is procedural and setup is a template method pattern from object-oriented software, and so maybe we would get away from that in a functional language. But it turns out the people who have been working with unit tests are so comfortable with their styles of testing that it doesn't matter which language you jump between. The vast majority of the X unit, test unit, whatever unit, prefix anything unit frameworks, they all are extremely similar. Some frameworks are starting to diverge, and it gives you a different approach to testing. For example, like the quick check and the quick check derivatives, those are different, but I don't know that it would be fair to say that those are unit tests. I think that's kind of a different style that maybe will evolve on its own, or maybe will get rolled back in, but it's still early days. And all the existing testing frameworks are just, for better or worse, they're very similar. So I find my style to kind of transfer between languages.
Fair enough. Okay, so is there anything else you'd like to add? Did we miss anything? Should I have asked you something that we didn't talk about?
I guess the only thing I would add is that I hope more people find this stuff interesting. I hope more people, instead of giving up on tests, they look for ways to increase the value, the ROI on the tests that they are writing. And I mean practitioners, and I also mean the people who are out, the experts, if you will, that are out in the world. I think Kevlin Henney presents fantastic stuff on testing. I think his style is different than mine, and that's okay. I think he still has a lot of value to add. I think Michael Feathers has a lot of value to add. Brian Merrick has been really focused on the testing space for so long, and he has a lot of value to add. But we don't have a lot of mature documentation. So I think people that are looking to get more return on investment are going to have to stick with blog posts and with presentations, recorded presentations at this point. And that's really the best we have, and that's fine. And we should be looking out for each other and pointing those out whenever they come up. You know, unit testing is a little boring, if you will, these days. But isn't it interesting that something that we find so much value in and is so old and we consider boring is still being thrown out by people that we respect? I mean, there's some type of mismatch there. And so hopefully more people will write more stuff on this. But I don't think we're there yet, unfortunately. And I hope people do try to find their own ways to be more effective, and I hope they write about those also. And I think other authors should get involved and start writing about their own styles of testing.
Good. So thank you very much for talking to me today, Jay, and thanks to listeners for listening.
Thank you very much.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.